A Nigerian scientist is leading a revolution across Africa, combining groundbreaking research at Harvard University with a mission to empower the continent's next generation of innovators. Dr. Olakunle Jaiyesimi, a postdoctoral fellow at Harvard's Extravro Lab, specializes in metabolomics, the study of chemical fingerprints in biological processes. He described it as biology's ultimate precision tool. His research uses fruit flies as biosensors to detect the metabolic impacts of oil pollution in the Niger Delta, creating an early warning system for environmental and human health risks. But Jaiyesimi's impact extends far beyond the laboratory. He founded STEM X Africa, an initiative training secondary school students across the continent in advanced technologies, including metabolomics and artificial intelligence. Jaiyesimi's goal is ambitious: reach all 54 African nations and prepare youth to tackle both local and global challenges. The Harvard researcher is also a founding member of Metabolomics Africa, a professional network working to increase access to cutting-edge science across the continent. And of course, postdoctoral fellow at Harvard University, Olakunle Jaiyesimi, joins now for a chat about the STEM revolution in Africa. It's good to have you with us.
Yeah, good morning. Thank you for having me.
Very good. Let's start specifically with this process of using fruit flies as biosensors to detect the metabolic impact of oil pollution in the Niger Delta. How was this conceived and how successful was it?
So this research was funded by the Motepe Foundation, which was a grant that was given to Harvard University. And thankfully, my professor at the Extravro Lab and I, with a collaborator at the University of Ibadan, Professor Professor Amos, got this grant. And the research was to use metabolomics and fruit flies to investigate the impact of crude oil pollution, on the health of the people who are living in that community. So we collected samples that related to the plants and the soil, water, and the fruit flies. And we all know that fruit flies have a lot of metabolic processes that are very similar to that of human. And so many of the diseases that are in human can actually be studied in these fruit flies, as small as they are. So applying metabolomics, since metabolomics can actually help to profile the small molecules, the global, small molecules that are in any living system, we were able to highlight, some biomarkers of crude oil pollution in these fruit flies. And so those biomarkers can be positioned to be able to detect the impact of this crude oil, even in humans and, in plants, as the vegetables that humans eat. So the process is such that, crude oil pollution seeps into the soil, and the plants take up some of them. And of course, humans who eat the vegetables also take some of the contaminants. So it's been a success. So we're at the stage of publishing.
Well, you've talked about how this research is aimed at improving or looking at the pollution at the Niger Delta, but you've also embraced AI-generated art as an outlet for creativity. How does this artistic practice complement your scientific work?
Thank you very much for that question. We, as humans, we are all created, or as living systems, which I study using metabolomics, we're all created by Olodumare. And I believe, the definition of Olodumare is the custodian of the mysteries of the universe, And when we were created, we were not created as scientists or artists or engineers. We were created as humans to dominate the entire universe. And so we have all of these skills as artists, as scientists, as all of that, that's the most important thing. So we just choose to compartmentalize knowledge. I consider myself to be a creative scientist. So if you use the three letters from each word, creative scientist, that's crazy. So I consider myself a crazy person, considering the fact that, I'm creative and I'm a scientist. So, and every living thing that you see combines those two, art and science. So if you see a beautiful flower, it's beautiful, that's art. But at the same time, the beauty of that flower is as a result of the small molecule.
Dr. Olakunle Jaiyesimi is a fellow at Harvard University. He was joining us and talking about the process of using metabolomics. Hopefully we'll get him back. We seem to have a technical hitch-up. Welcome back. Earlier on, we were speaking with postdoctoral fellow at Harvard University, Olakunle Jaiyesimi, who joins us about a chat about STEM revolution in Africa. I hope you're still there currently, Mr. Jaiyesimi.
Yes, I am. So sorry for the glitch.
It's all good. It's all good. So, how impactful is the use of metabolomic and artificial intelligence when we talk about advanced technologies, you think?
Yes, these are advanced technologies. As a matter of fact, metabolomics itself is a cutting-edge field that is just burgeoning, that is just emerging, even though within the metabolomics community, we don't consider it emerging anymore, but it's quite recent when you compare it with other fields, other related fields like genomics, transcriptomics, and proteomics, which have been around for much longer. So metabolomics is quite very recent. And of course, as we all know, artificial intelligence, even though a lot of people have been, utilizing it for quite some time, it's quite recent also for many of us. And so if you are able to integrate those two, metabolomics and artificial intelligence, you can imagine, how transformative that integration can be for the human race. And of course, particularly also for Africans and everyone.
Well, Mr. Jaiyesimi, your PhD work spanned medicinal plants from Nigeria and Brazil. What similarities or surprises stood out for you between the two countries and ecosystems?
The environment is very important, especially in specifying phenotypes. So in basic biology, we understand that your phenotype, that's your trait, is equally your genotype and your environment. So the genes that you were born with, and maybe that can change over time, but equally your environment is very important also in specifying your phenotype, whether you're a plant or a human or a fly or whatever you are. So collecting similar plants from Brazil and from Nigeria and applying metabolomics to them to discover drugs from these medicinal plants actually showed that, of course, they were variable even within the same species. There are quite some differences in terms of the compounds that they contain, the drugs, the medicinal compounds that they contain. But interestingly as well, even from Nigeria, similar plants or similar plant species that were collected from very close proximity, still had a lot of differences. And that speaks a lot to us as humans, twins living in the same house, eating the same food and doing everything together. We still have a lot of differences because, they don't exactly live in the same environment. And so, it comes down to the fact that every living thing is unique as much as possible. And that's the uniqueness that that person has been born with and that grown with, depending on the environments that they grow. And so when it comes to health, when it comes to your phenotype, your traits, your behavior, it is important to be able to go to the individual level. And metabolomics is so transformative that it can actually help in understanding the trait, the individual unique traits, that are peculiar to each individual. And that's one of the reasons why we're actually, trying to increase awareness and accessibility to metabolomics on the African continent.
Very good. Dr. Olakunle Jaiyesimi, postdoctoral fellow, Harvard's Extavo Laboratory. We'd like to thank you for your thoughts on STEM technology and, of course, related innovations on that aspect of science. Good to have you with us.